Math 20-3, this is lesson number 1, reviewing right triangles and trig functions. It kind of continues from the foldable that we did the last lesson. So the first thing that you need is you need the handout that was given to you this morning that says reviewing right triangles and trig functions. It says Unit 5, trigonometry. Don't worry about the unit number, but this is the handout that we'll be working through today. So let's review some properties of triangles, things that we know. The angles in a triangle add up to 180 degrees. If a triangle has a 90-degree angle, we call that a right triangle. And finally, the side that is opposite the right triangle is called the hypotenuse. And then we have the Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse. So all of this stuff is summarized pretty much at the top of your page. And then we have the 3 trig functions. SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So there are 2 definitions or 2 ideas that we need to become familiar with. The first is the angle of elevation. So the angle of elevation would be if I'm looking straight ahead, there's my horizon. If I have to look up, the angle I make from the horizon looking up becomes my angle of elevation. If again I'm looking horizontally and I look down, that becomes my angle of depression. Okay, those are good terms to know. So let's look at the first example. This is halfway down that first page. How tall is the cliff? So what I have here is I have an angle that's given to me. I'm laying down on the ground and I'm using an instrument that allows me to calculate, a clinometer is what it's called, and it allows me to calculate my angle of elevation. So I'm 500 feet away from the cliff. In relation to my 30-degree angle, what do I call this side? Adjacent. And what do I call the side for the height of the cliff? We call it opposite. So if I go back to my idea of SOHCAHTOA, the trig function that has opposite and adjacent is tan. So I have tan 30 is the opposite, which is h, over the adjacent, which is 500. To get h by itself, I'm going to multiply this side by the 500. And when I'm done that, I get 288.675. So to the nearest whole number, because that's what the measurement is given to me as, I get 289 feet is the height of the cliff. So what you can do at this point is you can either work through the next page in a bit, so the 2 triangles at the bottom of the page, and then the triangles, the 5 that is on the flip page. And then you can look at example number 2, or you can continue playing, look at example 2 now, and then you'll spend the remainder of class working on all of the other questions from this worksheet. So example 2 talks about solar panels. Self-facing solar panels on a roof work best when the angle of inclination of the roof, that is, the angle between the roof and the horizontal, is approximately equal to the latitude of the house. The latitude of Fort Smith in the Northwest Territories is approximately 60 degrees. Determine whether this design is best for Fort Smith. Justify your answer. So again, if we read through this, the angle between the roof and the horizontal. This is my angle of inclination that I need to find. So in my angle of inclination, I have that this measurement here is 9 feet, and this measurement here is 12. Not the whole thing. If it was the whole thing, the 12 would be in the middle. But this measurement here is 12. This is the angle I need. So we call this my opposite side, This becomes my adjacent side. So I'm back to using tan again. Tan of this angle, and I can use that Greek letter theta, equals 9/12. To get theta by itself, I have to take the inverse of tan. So theta would be tan inverse of 9 divided by 12. If you take a moment to do that on your calculator, we get 36.689, which is 37 degrees, which is not close to the 60 degree that I need. So is this solar panel the best for Fort Smith? No, it's not. If we look at the follow-up question says, what would I have to do to change in the roof design in order to make the solar panel work properly? Would I need my roof to be steeper, or would I need it to be shallower? So we can play around with this. We can guess and check. If I made or tried to make my roof steeper, that means I would make my rise larger. So instead of having 9/12, what if we had had 18/12? What would that do? So if I went tan inverse, 18 divided by 12, what would I get? So take a moment to try that on your calculator while I do the same. And I get 56 degrees. So it's closer to my 60. So now I know I would need to actually increase the pitch of the roof. So I could up that. I could try 20/12. So if I went tan inverse 20 divided by 12, I'm at 59. If I went 21 divided by 12, there's my 60. So tan inverse of 21 divided by 12 gives me my 60 degree pitch that I need. So as I said before, what you'll do for the remainder of class is finish up the questions on that worksheet. You're going to give that to me, and that's what I will mark for your marks.